So, our measurement review. Let's take a look and start off with a couple things. If you're watching on the video, you'll want to have the slides from AP pulled up as well, because you can't see the slides I'm projecting, but you can have them beside you as we go. All right, so again, quit smiling. It's not funny. Accuracy and precision is something that is often brought up in your AP questions, so it's going to be important to make sure that we remember the general difference. I do want to bring up just a general note-taking point that while I write several things on the whiteboard while I talk, I don't write just as many things that I say. So the point is, now see, those of y'all that are squinting and stuff, make it so you never have to squint again. Get the slides done before class. Anyway, you're going to want to be in the habit of writing as much of what I say as you can. All right, that's a college thing anyway, as I'm sure you've been told multiple times from multiple sources. So I'm not going to write down the definition of these, so just be ready to write them as they're dictated. Anybody have a quick definition of precision? You remember? It's a value that can be repeated. A precision is a measurement that you can repeat over and over again. Like, imagine stepping on a broken scale. Let's say I went home and I stepped on a scale and it said 401 pounds. Do you think that's right if I'm the one stepping on it? Like, yeah, fatty. No. No, it's probably not right, at least not yet, okay? But if I stepped off the scale and stepped back on the same scale, what would it probably say? 401, because that's how broken scales work. They just keep being broken. But if it does that over and over and over again, the scale is being precise because it's giving you the same repeated measurement. But what is it not being? It's not being accurate because accuracy is defined as being to the true total, as hitting the numerical target, if you want to say it like that. But accuracy has to do with the number being correct when compared to a known value. So on the slide, you can see that we're using the most classical example of precision versus accuracy, which is a dartboard. So based on the throwing of the darts, that first question that you were squinting at, says which of the measurements, and by the way, they're labeled A, B, and C, just going straight down. So which ones look precise to you? A, B, C. Just do a shout out. I would say B and C. All right, because remember, precision is just the ability to repeat results. Now, obviously, whoever is throwing the darts on choice B is just terrible at darts. They're losing. But they're able to repeat their throw over and over again, which is precision. All right, the C person is doing the same thing. It's a different spot on the dartboard, but it's precise because it's repeated. Which ones are accurate? Only C is the way it appears on the surface. Now, you're right. C does appear to be accurate because on a dartboard, your goal is to hit the bullseye. Can anybody remember, though, how accuracy can be a little more interesting than just hitting the target? You can average your results for something to be accurate. Now, this dartboard here might not give you enough information to verify accuracy, but look at throws A. Look at the person that threw on A. Do you see how someone could possibly pose the argument that if you averaged all the throws together, you'd be on the bullseye? All right, not for sure. You're right. Some people, look at that upper right one. He sucks. No, but there's an argument that maybe you could average the throws to accurate. So make sure you have a note in there that if you're given a data set, a bunch of numbers, and it's supposed to be 27, and none of them are, but you can average them to 27, then the data set's actually accurate. So you'll see those two vocab words show up in a variety of different ways, so knowing those basic differences are important. Do you have any questions? I'm just kidding. Oh, look, you laughed. You're famous. Here, toss me him. Toss me him. What's his name again? This is Wegoe? Wegoe? Wego? Okay. I'm done. Let's move on to our favorite thing. Significant figures are going to play a role in every single unit that we do, guys. They are graded on the AP. You don't miss the whole question if your sig figs are wrong, but they will happily take points away here and there. So hopefully you remember how these work. So let's go ahead and revisit our sig figs. Rule number 1 that you're hopefully not having to write. Seriously? Anybody see a black marker? Oh, on my desk. So the other thing is I have to use primary black marker when recording because the other colors don't show up very good on the whiteboard due to a glare. Anyway, okay, non-zeros are significant. So what we're doing here is we're counting actual digits in a value to figure out which ones are significant. It's putting the numbers backwards. So with your 3s, shoot. I can? Yeah, but this isn't Snapchat. How do you know this program does that? Because I used a different program. I'm sorry you have to see this. It'll let me do that? Is that going to put me on this side? Because that'll be weird. All right, you're gonna help me do it, Wiggly. Here we go. All right, so if the value looks like that, it's 2 sig figs, right? This would be 2 sig figs because neither of them are zeros. Even though they're the same digit, it doesn't matter. You go digit for digit. That was a naked number. You should have yelled at me. Make sure you've got units after your numbers. Rule number 2, sandwiched zeros are significant. This rule refers to zeros that are not starting or ending the number. So we can make this number become 303 grams. I feel like you're showing off. How many sig figs do you see there? 3, all right? Non-zero, non-zero, sandwiched 0. This is 3 sig figs. The third rule, zeros that end a number are sometimes significant. This is the one where you have to see if the author of the value showed you a decimal or not. So if we change this to 300 grams, written in that way, how many sig figs do you see? Only 1. Because in this value, I have not shown a decimal. Therefore, all zeros, and they come as a package, will be insignificant. Now remember, if the decimal shows up, though, it doesn't matter where. It's just if there's a decimal anywhere in the number, all of the zeros at the end immediately become significant. So we can make this 0.3, we can make it 30, or just 3, we can make it 30, we can make it 300 with a decimal, and all of them would give you the same result. But let's go ahead and just make it 30 grams. That's my last rule. How many sig figs down? 3. The non-zero. And then these zeros are significant because there's a visible decimal. It's either all or nothing with trailing zeros. The last rule. Starting zeros are never significant. If we keep with our trend of 3s. How many sig figs do you see? There's only 2. Now I understand that some of y'all get thrown by this 0 right there. You're like, but sir, there's a decimal and a 0 and a blah, 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 blah. All right? A decimal can only affect zeros at the end of a number. Zeros at the end of the number always refer to the right-hand side of the value. All right? So these are both leading zeros, starting zeros, so neither of them are significant. Now, I want to point out an important idea. We want to avoid dead babies. And I know that sounds just like a thing that I would say. But it's a real thing, because it turns out that back in the day, doctors would sometimes accidentally write things that would end up killing children. And what I mean by that is they would say something like this. They would look at it, they would look at a report, they would look at a medicine that a baby needs, and they would write down on the report, give them 0.25 milligrams of this medicine. And it would get passed from a couple people. And what dosage do you think could accidentally be given? 25 milligrams. All right? That is a huge difference than 0.25 milligrams of a certain medicine. All right? And what happens to the baby if you do that? It dies. So, what do you think is the, when I say avoid dead babies, what do you think I'm telling you to do for a number that looks like this? That's what you need to do. All right? For those of y'all that had me last year, I always did that when I was in class. And sometimes y'all would ask, and I'd be like, the decimal's hard to see from the back of the room sometimes. So I need you to make sure that you can see the decimal there by that leading zero. Doesn't matter if you add the zero because it's never significant. So it can never throw off your value. So no dead babies. Lead with a zero if your number's small. All right, you try one. We're going to be drawing a card here in a moment, so make sure you have an answer. I just want to know how many sig figs there are in this value. What does MG stand for here? What was it? Megagrams, that's correct. A's a big M. Who's a big M? Yeah, not magnesium, please. Yeah, that is megagrams. All right, so let's head over to cluster 6, seat 3, which is Aspen. Aspen, what did you get? How many sig figs do you see? She says 5. Do you agree or disagree? I agree too. Good job. That last period's AP class that totally changed their answer. Yeah, you can pass Aspen to the next person. And yeah, we got non-zero, non-zero, sandwich zero, ending zeros sometimes. Do you see a decimal? Yes. All right, then they are. And starting zeros never are. All right, hooray, no dead babies. 5 sig figs. Yeah? Okay. Sig figs are going to be important in a few different ways to look at them. Like when we're taking actual measurements in the lab, it's important that you know how to look at like a ruler or a graduated cylinder and understand how many sig figs it's able to give you. And also when you're adding, subtracting, multiplying, dividing, you know what the calculator likes to do. You divide two numbers and it gives you 12 numbers, and there's only a certain amount of them that you're allowed to report. So we're going to go over those steps, how to round, and make sure that you can do that on the AP. So let's start off with these measurements. If you're measuring with actual devices in regards to sig figs, here's the rule. You are allowed to do every graduation that the measurement has. All right, you can go out to the numbers that it specifically measures for, plus a digit. You get to estimate one additional sig fig beyond what the instrument is graduated for. For example, if you notice on the top labeled ruler there, you'll see that it goes out to the tenths place. It goes 2.1, 2.2, 2.3. All right? So how many sig figs is it allowed, though? Well, look, it estimates the hundredths place, which is 1 digit more than what the device looked like it was capable of doing. If you move down to the bottom ruler, and again, you should be looking at the slides while I do this, you'll notice that it only measures to the ones place. All right, it only measures once. But what did the measurement predict or estimate? The tenths place, 1 sig fig further. With that in mind, I want you to report the correct measurements of the other two devices on the slide. I'm going to draw cards for both of them, so come up with answers. I want you to predict the measurements of the other two devices. While you do that, I'm giving you restroom passes right now. You get 2 and 9 gigs. If you save one for the end, I'll throw you some bonus points. If you need to go, don't ask. Just deliver it to me no matter what I'm doing. You can go. All right, let's pick on some people. This is so much better on my back, y'all. Don't have to bend over and pick up dice. All right, let's go to cluster 6, seat 1, Aspen. What did you get for the graduated cylinder? Okay, that's fine. You don't have to give me so 38. Y'all agree or disagree with the answer 38? I disagree. That graduated cylinder is graduated to the 38 mark. Don't you agree? Every one of those lines is worth 2 in between? Yes. So you don't get, that's not where you stop. If it can measure to 38, what are you supposed to do? You go one, not 39, you go 1 digit further. So what's the answer? 38 point, I would say 0.0. It looks like it's right on the line, right? So you want it to be 38, but your prediction, your estimate would be 38.0 because you always go 1 sig fig further than what the graduation actually measures. 38.0. Questions on that conclusion? Hey, can anybody tell me what the point is called where you measure a graduated cylinder? It's a vocab word. It starts with an M. The dip in the water. The meniscus. That's a good vocab word, meniscus. Anyway, let's go to cluster 2, seat 3 for the other one. 1.25. Do you agree or disagree? I agree with that one. All right? Because if you look, it's capable of measuring 1.1, 1.2, 1.3. So those to the 10th place is measured. So what did he do? He went 1 number further to the 100th place. Yeah? Okay. Before we advance the slide, let's talk about rounding. It breaks my heart the amount of students that struggle with rounding. So hopefully this is the most boring part of the entire lecture today. But take a look at this value. (1,567 kiloliters). I want to round it to 2 sig figs. I want to round this number to 2 sig figs. What you need to decide is which 2 numbers are the most important numbers in the measurement. They will always be the numbers furthest to the left. Well, the significant numbers furthest to the left. which means if I'm going to round it to 2 sig figs, well, those are the 2 numbers that I definitely have to keep. The other numbers are going to go away. Now, while that number is just going to completely go away, what's true about the closest number that's going away? Yeah, it's got a little bit of power to affect the number next to it. By rounding rules, if that very first number that you're getting rid of is between 5 and 9, it's going to push the number next to them up a digit. If it's less than 5, it will just do nothing. Is that 6 going to affect that 5? Yes, it's going to bump it up 1. And now somebody finish my thought for me.
0,
0, 0. Many students become guilty of not adding the placeholders. I promise you, if I owed you $1,567 and I rounded it to $16, you would be all up in my face. All right? So you have to be rational while you're doing this. All right? You can't round that to 16, but I can round it to 1600, and as long as you don't show a decimal, those ending zeros are not significant. And now you've got 2 sig figs. It's already 4 sig figs. Yes, yeah, okay, no, okay. So if this is what I gave you and I said round it to 4 sig figs, yes, just boom. Now it's 4 sig figs. Well, I mean, but in this case it does because you don't want to make it 160. You want to make sure the number still makes sense. All right, you try one. Round it to 2 sig figs, please. If I can't turn around these backwards numbers, I don't know what I'm going to do. Yes, there you go, Diego. You know what? You don't have to come to school on Monday now. Let's draw somebody. Let's go to cluster 2, seat 6. Very much as you. 2 sig figs. What'd you get? Just tell me what's right. Which 2 numbers are the most important numbers to keep? 4 and 0. Perfect. All right. So he's going away. What is he going to do? Okay. Boom, look at that. Man, I hope I can take the test with you. All right. That is your correct answer. Remember, those leading zeros are not significant. Are there any questions? What time do we get? 51. So, how do we apply it? Let's remember. It turns out that adding and subtracting sig figs have different rules than multiplying and dividing them. So let's start off by talking about adding and subtracting. Look here. Copy your slides down beforehand. You are killing me if you're writing and not listening to my awesome voice. When you're adding and subtracting and looking at sig figs, all they care about is the number of digits that are appearing after decimals. That's all that matters. Whichever of the measurements you start with that has the lower amount of numbers in the tenths, hundredths, those smaller than 1 places to the right of the decimal, dictates the number of decimal places allowed in your answer. For example, there's an addition problem full of naked numbers. What I'm saying is the answer there can only have a number of digits to the right of the decimal equal to the starting number that had the least amount of numbers to the right of the decimal, which was what? How many decimal numbers is our answer allowed to have? 1. All right, this number had 3, this number had 1. Our answer can have 1 digit to the right of the decimal. And that's the only rule that you have to follow when adding and subtracting. So other than that, put it in your calculator and round. We'll draw a card. We're going to go to cluster 4 this time. We're going to talk to seat 4. It was a 4-4. It's a pocket pair, y'all. Whoa. All in. Whenever you're ready, Rob. I'm sorry? Yeah, just tell me what's right. Agree or disagree? I agree. I think she did beautifully. Multiplying and dividing are different, and that's what you actually do a lot more in chemistry. It tends to be is the multiplying and dividing. But the answer that you get from multiplying and dividing can only be equal to whichever of the measurements has just less sig figs. That's how many sig figs your answer will have. So think about 4 times 4 for a moment. It's a real brain scratcher. According to sig figs, what is 4 times 4 the way I've written it? It's 20. Why is 4 times 4 20? Well, 1 sig fig. 1 sig fig. Our answer can only have 1 sig fig then. The least precise measurement dictates my answer. We know that this is 16, but I can only keep 1 sig fig. The 6 is going to go away. It's going to bump the 1 to a 2, and you add a placeholder. You try one. Solve. Let's go to cluster 6, seat 5 Aspen. What'd you get? Sorry? Sarah, so working with me. How many sig figs do you see in this expression right here? All right, 4. And how many sig figs do you see in this expression here? 2. Perfect. So how many sig figs can my answer have? 2 is the correct answer. All right. So when I run it in my calculator says 0.8104. That's what the screen says. But I can only keep 2 sig figs. So that 0 is not significant. I want to keep the 2 most important numbers. We're going to get rid of that number. We're going to almost completely get rid of that number. What will the 0 do to the 1? Nothing. You can pass Aspen. Yeah? The conversions between prefixes and units is going to be important. All right, if y'all, please don't copy it. Just get it later. Just add it to your notes later, guys. You're going to get sharper at this. I know it's the first lecture. You can use dimensional analysis to convert between these. I think that decimal slides are easier, though. So here's the thing to write down. Here's the thing I always have in my head when I'm doing this. Write down that if the unit gets smaller, the number gets bigger. If the unit gets smaller, the number gets bigger. And I'll show you what I mean. If the unit gets smaller, the number gets bigger. For example, if I had 0.033, what is that? What is that? It's great-grandmother. That's what we call my great-grandma. She's Gigi. It's gigagrams. All right? And if I want to know how many megagrams that is, all right, well, are my units getting bigger or smaller? The units are getting smaller, yeah? So what should the number do? The number should get bigger. So if you have that in your head, it tells you which direction to slide the decimal. The units got smaller, so I want this number to get bigger. There's only one direction to slide the decimal to make that happen, all right? But the question is, how many times do you slide it? Well, really, you need the 9 to slide to the 6. How many times do you have to, how many increments do you have to move to make a positive 9 become a positive 6? 3. So I'm going to slide it 1, 2, 3 times. 0.033 gigagrams is the same thing as 33 megagrams. I slid it, I made the number bigger because of the direction of the units. I slid it 3 times because that's how I get from a 9 to a 6. You try one. If I have 750 microliters, what? I'm sorry, my notes are messed up. I want to know how many hectoliters that is. Should the number get larger or smaller? My units are getting larger, micro to hecto, so the number should get smaller. So I know right away I've got to slide the number to make it a tinier number. The decimal is currently right here, even though it's not shown. So then the question becomes, how many slides does it take to get from micro to hecto? So really you're asking yourself, well, if you're at -6 and you need to get to +2, how many increments is that? It's 8. All right. If you need to draw a number line, draw a number line. Or I can show you how to do this with dimensional analysis, but this is easier. Yeah, it's going to be 8 slides. So 1, 2, 3, 4, 5, 6, 7, 8. And of course, these will all create zeros. I would never write the number like that, though. I mean, you can. It's not technically wrong, but I would go 7.5 times 10 to the 1, 2, 3, 4, 5, negative 6. Both of these are the same number. If you look online, you'll see that there was one more question I was thinking about going over. Just do it on your own, and if you don't understand that simple conversion using conversion factors, message me. Y'all have a great weekend. Don't forget to have your slides ready for Monday.